Hello, ladies and gentlemen, and thank you for joining me once again. Root Beer here with question 5 on the 2011 Grade 12 Euclid contest. So for A part, what is the largest two-digit number that becomes 75% greater when its digits are reversed? So we got to focus on the digits of our two-digit number. So what I'm going to do is probably write my two-digit number like this, 10a plus b. Now, this is how you write things where the digits are A and then the unit's digit is B. Okay, so that's the number. And then reversing the digits would be B goes in the tens digit and A goes in the units digit. And so by reversing, we go up by 75%. So how do you increase by 75%? Well, you multiply by 3/4 and add that on, or you could say you multiply by 7/4, whatever you want. So we know my new number with the digits reversed, BA, is 7/4, that's a 75% increase, of 10A plus B. And now we have a nice little equation. I'm going to multiply by 4 on both sides, so 40B plus 4A is 70A plus 7B. Just a little nicer to work with these. And remember, A and B are going to be single digits, so 0, 1, 2, 3, all the way up to 9. Neither A nor B should be 0 because you can't have a leading 0. Okay? 0, 9 is not a two-digit number. It's just 9. Okay, so we have 33B is the same as 66A. Divide by 33 on both sides. B is 2A. So if our theory is, if our arithmetic and our theory is correct, we should be able to increase something by 75% by swapping the digits if the tens digit starts out as half of the units digit. So something like 12, switching it around to 21, that's an increase of 9. Well, 9 is 3/4 of, or 75% of 12. So this works. So what's the largest we can possibly have? Well, at most B is 9, but 9 isn't twice something, so we would have 8. So 48 would switch around to 84, and that's an increase of 36. 36 is 75% of 48. So what do they want? The largest number that when the digits are reversed becomes 75% greater? So our final answer is going to be 48. And there we go. So that's our A part done. How about our written B part? A triangle has vertices at 0, 3, 4, 0, and K5. I don't know what this K is, but I do know K is between 0 and 4, strictly between 0 and 4. If the area of the triangle is 8, determine the value. There should just be one value of K. Okay, so what can we do? What can we do? Well, I'll draw a little picture here. Maybe with some nicer axes. That's a little bit better. Okay, so we've got, there was 0, 3, and 4, 0. I don't think it really matters, it's just a reflection. But, okay, there we go. And we know K is somewhere, but we're up here at a height of 5. We definitely know we're at 5. So we're talking about this triangle right here. Now we know its area needs to be 8. Can we think of a way to calculate this area in terms of K? Because then we'll get a nice equation where blah, blah, blah in terms of K equals 8, and then we can solve for K. Well, knowing that K has to be between 0 and 4, we know that we're just on this little line segment here. What I'm going to do is I'm going to sort of box in my triangle with a big rectangle here. Now, this rectangle, in order to get the 8 here, you take from the rectangle, who's got dimensions height of 5, width of 4, so the rectangle has area 20. Now, it's a written question, so you might want to say enclose the triangle with the 4x4 rectangle shown. Or you could probably say things like, we'll let this be A, B, C, D, E, and F. Then you could say something like area of triangle CEF is 8. but it's also the area of the rectangle ABCD minus this triangle up here, AEF, minus the triangle over here, BCF, minus CDE. Now, all of these are nice little right angle triangles. I know this is a 4, this is a 3, height of 5, so this is a 2. Now, I don't quite know where K is. So we know that this length over here is going to be K, and then this should be 4 minus K. But this gives me 8 is equal to 4 times 5, the dimensions of the rectangle, minus 1/2 base times height, 2 and the K, minus 1/2 base times height for the 4 minus K, 5. Nice little right angles here. Minus 1/2 3 times 4. So 8 is 20 minus 2 times K times a half should just be K, minus 5/2 4 minus K. I'm going to write that as 10 minus 5K over 2, right? Yes. And then minus 6. So, okay, let's leave the constants on their side. So we'll have a K. Now we've got minus, minus, and we're bringing it over here. So it'll be another minus. Minus 5K over 2 is 20 minus 10 minus 6, and we bring the 8 over, so minus another 8. So 10 and 14, so we'll get 20 minus 24, so negative 4 should be 2K minus 5K over 2. Multiply both sides by 2 and simplify, so we'll get minus 3K should be minus 8. K should be 8/3. Okay, and if we want to, we could double check. Some things like do these areas make sense? This one's always going to be 6 and 8, but what are these ones over here actually? Well, this will be 4/3 times 5 times a half. So that'll be 10 over 3. And what have we got over here? It'll be 2 times 8/3, so that'll be 16/3 times a half, so that'll be 8/3. 8/3 plus 10/3 will be 18/3, or 6. So these two combined to be 6, another 6, and an 8 does make 20. Okay? So we've got our final answer. K must be 8/3. So we found the area in 2 different ways. One, they gave it to us. The other one, we used the bounding rectangle, made some triangles, and we got an expression in terms of K. And then it was just some algebra. All right, so that does it for question number 5. Up next, if you'd like to join me, will be question number 6. So we're halfway done the paper, just in terms of the number of questions. Hopefully question 6 will be fun, but we'll find out next time.